Number 9, this is page 11. Again, did not provide you enough room, so encourage you guys to put it on a separate sheet or on a scratch sheet. So we knew how to find the A value. The difficulty, I think the most difficult part is just understanding the need to adjust the equation, especially if theta is not by itself. We have to force that 1/4 out. And because there's a 4 that's pulled out, we have to make an adjustment with the second fraction, and we got to include the 4 on the other side. So there's a 4 in the denominator that gets pulled out. We need to balance it out with the 4 in the numerator of the second term. And then we can do some cleanup if we can reduce that 4 power over 8 reduced to be power over 2. And then we have our A value, we have our B value, we go through our period formula, we go through our interval formula, and we know that our phase shift is power over 2 to the right. But we're going to do that at the last step. Right. First, start off with your 0, add your increments until you reach your period length. And then you build your cosine parent y value. You can also then multiply by the A value with the original cosine y value. And then you understand that phase shift is moving to the right, so we got to add pi over 2 to all the original theta x values. And then we add. If it's a fraction, we have to find common denominator. So think of 2 at 4 over 2. Think of 4 at 6 over 2. Think of 12 over 2. 8 at 16 over 2. And then we find the updated x value. And we understand that we're looking at the highest and lowest first and last row. Okay, those would be the order pairs that we are graphing. So we're starting at pi over 2, and then we're incrementing all the way to 17 pi over 2, and the order pair is pi over 2 comma 6. You can adjust and label whatever, as long as you label your graph, make it as wide or as thin as you like, as long as I see where those order pairs are. And you can see that this resembles the cosine graph. We're just taking it, shifting it, and stretching it, and making it longer. So it doesn't have to be to scale, right? As long as you label your points, that's what's going to be for it. Okay, any questions with 9? Okay, let me find one more for us to do, and then I want to do 13, 14. So let me see. Okay, let's do 11. Yeah, 11 will be a good practice for us because we got some messy fractions that we have to go through. So I think that'll be a good one to do. So number 11. Walk us through every step, especially the first step. One is a little messy because what's out of place? 3 pi, good. So we want that theta by itself, so I need that 3 pi completely outside, separated from that theta. So that's gonna make an impact with what comes inside the parentheses. set it up, but I know that solve some part of trying to figure out what goes in that space. So I pull the 3 pi out, which means I have to adapt a 3 pi where? Well, this is the numerator, right? So I got to balance it out with 3 pi where? In the denominator, right? So let me show what that looks like. So it's pi over I think this is the most challenging part here. So if we can get this under our belt, I think that'll be a good step. So is everybody okay with this? Understanding what comes out, understanding that think, okay, is that a numerator or denominator? Okay, that's the numerator. I'm going to balance that exact same term in the denominator of my new fraction. So now we can do a little bit of cleanup, right? Because we don't have to hold that all the way through. That's just the starting point so that we can move forward. What is pi over 3 pi? Yeah, cleans up to be 1/3. Good. Now we should get this forward, right? We have our A value, we have our B value, and we can deal with that phase shift. Following the formula, right? P equals 2 pi over B. We get our new period. Then we take that new period, put it into the interval formula, dividing by a number or same thing as multiplying by a reciprocal. Okay. Phase shift. What's the phase shift here? Good. Left 1/3, right? I think opposite. Everything before we work in the phase shift. Any questions? Purposely keeping all the denominator at 6 because I know that it'd be easier by for my, when I have to add a fraction later on, I have to have everything, with things on. So far. Okay, so now what do I need to do? Spaceship, so what's the operation here? Subtraction, right? Subtracting 1/3, can I quickly make that easy fraction to do here? So 2/6, I'll subtract 2/6, all right, get that denominator to match. Put the result above, put a box around it as a reminder. Okay, that's my final x value that I'm going to be worrying about. That resembles a cosine graph, just reflected, right? So starting at the peak and making its way to the minimum and then rising to the peak, it's the other way around. We're starting at the minimum, rising to the peak and falling again. And we see that with the cosine graph that's been shifted to the left. Okay, any questions? Okay, we're going to look at 13 and 14. Go through this in detail here. We're going to write. Okay, so okay. Everybody good with 11? Everybody still need to look at 11? Good. All right, so 13. 13 says write a sine and cosine equation for each graph. Let's use the space above. Since hopefully we didn't do anything in this space here. Let's cross out 11 and 12. And I want to make sure that we have plenty of space for the work that we want to have for 13 and 14. Says write a sine and cosine equation for each graph below. First, you can see that you can figure out where your 5 points are, right? You have your 5 points here, 1, 2, 3, 4, 5, right? There's your 5-point summary there. Okay, let's do the easier one, okay? Which graph does this look like? Or which graph is it? cosine, right? Because cosine starts at the peak, goes to the bottom, goes and it rises to the peak. But and basically the cosine graph is just basically reflected, right? You can have it start at the peak by just reflecting it. So it's basically the cosine graph. The cosine is just the peaks and valleys on the y-axis. But we have to build enough information here. So then we have to get in this form. Y is equal to A cosine B theta plus C. Okay. All right, let's start with the easy stuff here. What do you think the A value is? So we know the amplitude is 4, right? From rest to crest, so from the center, the middle line of your graph to the furthest point, that's 4, but it's reflected, right? So we know A is what? A is -4. So we'll set that to the side just to get that easy stuff out of the way. I know it's reflected. Yeah. So we know that the cosine graph starts at 1, 0, -1, 0, 1. Right? So it starts at the peak, goes to the minimum, and goes to the peak. But here, if you cover this graph up, you kind of imagine that this is a reflected graph because it starts at a minimum, goes to 0, to max, down to 0, and down to the minimum. Right? So if we're starting at the opposite end of where you expect your cosine to graph, you know it's going to be reflected. Okay, next up is looking at the period. Okay. The period is looking at from cycle to cycle here. From -2 to pi/2, we see that we go from peak to peak. That's one cycle. What is the length of that cycle? So let's look at this here. This is pi/2, right? This is also what? Pi/2. So what's pi/2 plus pi/2? Again? Wait, what's 1/2 plus 1/2? 1, right? So that's just pi, right? Remember, when we add fractions, we add the numerator, but we keep the denominator the same, right? 1/2 plus 1/2 is 1. So you know that your period is pi. But we have to make some adjustment, right? We got to get to the b value, so we got to work through the formula to get to the b value. Why is it not 3/4? The reason why is because if you just look at 3/4, it hasn't completed its cycle yet, right? If you start at -4, and if you end at 3/4, you haven't finished the cycle. You have to remember you always start and end at the same spot. So you could extend this a little further and convince yourself that if I start at 0, I should be able to make my way to pi, and that you can also think of that as your full cycle. Right? But here I'm counting from peak to peak because I see it, but I could also start at the minimum and follow it through to the end. Yeah. Yeah, right. You look at the original equation. The original equation is peak, center, minimum. And here, this is minimum, center, peak. So basically, if I cover that up, I can convince myself, okay, that's reflection of the cosine graph, right? Cosine graph's going to start here and make its way down. So our period is pi. We got to go through our formula. Our formula is period is 2 pi over b. So just like on the quiz, we have to kind of work backwards, right, to get to our b value. So I'll put the pi in for the period. Cross multiply. B equals what? 2, okay? Now, is there any phase shift here? Not for cosine, because we're starting on the y-axis, right? It's just reflected, but it's still starting either at the peak or at the minimum for cosine. So this one is not reflected. This one is good. So there's no need for a c-value, or c-value is 0. This makes it an easier graph to do because we don't have to worry about the phase shift. So we have everything that we need. We have our a value, we have our b value. We can just ignore the c. So we have our equation that we can go ahead and write. I don't have to worry about all that bracket parentheses because I don't have to worry about that c value. So I can just, I can put parentheses around 2 theta if I wanted to, but hopefully we've seen it enough where we understand that it's not cosine times 2 theta, it's cosine of 2 theta.
Wait, so why is there no phase shift thing?
The reason there's no phase shift is because if you think about the cosine graph, right? Cosine starts at the peak and moves its way down, right? Cosine starts here and goes down. So if I just reflected this to the other side, it basically is going to turn into a cosine graph. I just reflected it. Phase shift, right? I'm just looking at that. Now, the harder part is looking at it from the sine's perspective, because if I want to write this equation as a sine function, then there's definitely a phase shift because this is not the sine function. So this is a little bit harder, but I'm going to try to guide us through it. So any questions with part A? Building the easier function, building the cosine. Okay. Now, I want you to use a dotted line or a pencil, and can you create a nearby sine function by shifting the cosine graph? Okay. Where does sine graph start? 0, okay. And then it rises to its peak, back down to the center, and then to the minimum. Okay, so see if you can just create the cosine graph. Sorry, create the sine graph. And just put a dotted line, just so we can have a frame of reference. Be convinced that the dotted line that we have in front of us, ignoring the solid line, is a sine graph. Okay. Now, what we're going to do is we're going to pretend like we don't see that we don't see the graph that's given to us, and we're going to create an equation for that sine graph. And we're going to figure out, what can I do to shift that sine graph into the graph that's currently shown. Let's not worry about it. Let's just worry about getting to that dotted line, that sine graph. Okay. So a lot of things can carry over because your a value and your b value will carry through. Okay, it's the same. Remember, sine and cosine are just shifted versions of each other. So there is a slight adjustment here. For this sine graph, what's the a value? Just 4, right? The graph is rising, like as if it's how you would expect a sine graph. It's not the reflected version. The reflected version would be going down, but this is going up. So your a is 4. What's your b value? Same. Okay, it's going to be the same. So once you find a period for one cosine, the sine will be the exact same. Okay. You can also convince yourself that this is a period of pi, and go through that process, and your b value is going to be 2. Okay, so same thing. Now we'll put everything in place. The only thing left is do the phase shift. Okay, and we can do the phase shift at the end. So y is equal to 4 sine bracket 2 theta. So are we convinced that right now we have in front of us is the graph of the dotted line. Now, what we're going to do is we're going to try to figure out what can I do with the dotted line to make it turn into the graph that I'm trying to write the equation. What can I do with that dotted line to shift it in place to the dotted line? Shift it to the right. Shift it to the right. Okay. So let me write that out. We want to shift from dotted line to current graph. And you said what again? Shift to the right. Good. Right pi over 4. Now, how do we adapt right pi over 4 in terms of the equation? Got to do what? Well, this is already factored out, so we're okay. We don't have to make any adjustments. This is already factored out. Okay. We subtract because we want to go right, opposite, right? So minus sine over. The reason why we don't have to do anything with that adjustment with our b values because this is exactly as the way that we want it to be, right? If we were starting with something that's unfactored and trying to get the factored form, that's the only time you have to make an adjustment. But here, if we're building the graph the way that we want it to, we don't have to make an adjustment. We can just fill that in with exactly what we were hoping for. So a common thing that I saw on last year on the test that when the students saw this, I think the tendency is students want to start with the dotted line, start with the graph and try to work it to the dotted line, but it's the other way around here. I want to make sure that we create the imaginary dotted line graph first, and then figure out how do I get that imaginary graph to turn into the graph that is given to me. Okay, so dotted line to current graph. Figure out the phase shift of dotted line from the imaginary graph to the real graph. Okay, we'll save number 14 for tomorrow so we can get some more practice with this. But I do want to introduce the last topic, which is vertical shift. Okay, and vertical shift is easier than what we've done. So we're going to do is we're going to do everything up to the phase shift, and I'll show you what that vertical shift is going to be like at the end. So we're kind of just building layers on top of our previous problem. Okay, page 12. So a vertical shift is how far the graph moves up or down. And the way we can identify a vertical shift is we look at the number that is added or subtracted to the end of the problem. So it's completely outside the function, it's not inside a set of parentheses, it's completely outside. And that number that is by itself outside the function is going to either move the graph up or down. And this one is going to be more straightforward. A positive number is just going to move that graph up however many units. If it's +3, then it's going to move up 3 units. If it's -3, it's going to move it down 3 units. So the number outside is more straightforward. It's the phase shift inside that is opposite. Right is negative and left is positive. But the outside number up and down, that's straightforward. Okay. So looking at number 1 here, I see a phase shift. I'm going to rewrite it with the same thing every time here, with a 1. And I know that if I have a 1 outside, I don't have to make any adjustments with that p value. So let's talk about what transformations are occurring. What is that power of 4 going to do to the sine graph? Shift right. pi over 4. And what is that plus 3 going to do? Up, yep, up 3 units. Okay, so let's try number 2, just for practice purposes. We're going to rewrite it and see if we can figure out what to do with that, how to rewrite it so that we can get the correct phase shift. So okay, what's out of place here? That 3, got to take that 3 out. So I have a 3 in the numerator. How do I balance that with the second, with my second term? 3 in the denominator, right? So it's going to be so I need to multiply that number down there. That makes sense. So if I see a numerator number out here, I got to balance it out with a denominator. So let's clean that up. What's my new value here, C value? 5 or 6. Okay, so now we can list out our transformations, right? What is that 5 or 6 going to do to our cosine graph? Left. And what is this minus 1 going to do? Down 1 unit. Yeah. Okay, let's see if we can do a full example, and then we'll come back and do these word problems. I don't think these are bad, but it just takes more practice. But we'll come back to this. I want to make sure that we can get through a full problem with that vertical shift involved. So let's try number 8, and we'll just try to get through number 8, and then I'll pick up tomorrow. Okay, so number 8, this is on page 13. Again, separate sheet of paper will be best. Sorry, there's not enough room in the packet. Okay, first things first, do I need to do any adjustment with this equation? That theta is by itself, right? There's no number affecting that theta, so we're safe. But I like to rewrite it just so that every equation has the same form. Which means that the pi over 2 doesn't need to be rewritten. We should be good there. Okay, list out your values. VS is going to stand for vertical shift. What's our vertical shift here? Yeah. Okay, we'll do that at the very end, okay? So pretend like you don't see the vertical shift and just do the table, everything up to that point. Okay, so this is everything up to before the phase shift. How do we involve the phase shift here? Good. Left, so we're going to subtract. Okay. We already made the adjustment here. The plus is left, and then so now everything's more straightforward. Left is minus. Okay, we want to go left pi over 2. Nice to leave all those denominators the same. Makes it easier to combine. Okay, so we've done everything right before the vertical shift. Any questions so far? So the first column, the first row is good to go. That's the x value. But the vertical shift is going to affect the y value. Okay. Any guesses as to what we're going to do with these y values here? Subtract 3. Yeah, that's it. Subtract 3. So here, we'll just say minus 3. Okay, so 2 minus 3 is negative 1. Here, let's write out that word so we don't make we don't multiply it by accident. So 2 minus 3 is negative 1. 0 minus 3 is negative 3. Negative 2 minus 3 is negative 5. 0 minus 3 is negative 3. 2 minus 3 is negative 1. I like to do this here. Whatever this number here is basically going to be your new center. We call it the midline. So I like to put that dotted line here as a way of kind of centering ourselves. We know that whatever graph we draw, it's going to kind of center around that dotted line. Basically, our graph that was centered at 0 has now been shifted down, and it's just nice to have that as a baseline, as a way of kind of centering our graph a little bit, or at least visualizing that centeredness of our graph. But now you can highlight the top row and last row because these are the order pairs that you're going to be graphing. Go ahead. Okay, so my first order pair, negative pi over 2, comma negative 1. 0, negative 3. Pi over 2, negative 5. Pi, negative 3. 3 pi over 2, negative 1. Okay, it should resemble a cosine graph that's been moved all these different ways. So we can still see that cosine graph there, right? It's been shifted, it's been moved, it's been stretched. Okay, that's good. Now we've covered all the transformations and we can just work on the details tomorrow. Okay, we'll go over some final details tomorrow. I'll give you a quiz review. And then Thursday we'll have a quiz, but just like before, as a check-in quiz, we'll spend the first part of Thursday going over one full problem before you take the quiz. Okay, don't forget your phones. Because it was pi over 5, you have to divide pi over 5. You can multiply that. But what kind of process I think there's the.